Everyone, welcome to today's video. So today we'll be solving this problem up here. This is actually a quite common calculus problem that you might see on stuff like textbooks. And I got this problem from BPRP, Calculus Basics. It's a wonderful channel. I have it in the description. You should check him out. But by all means, of course, try out this problem and see what you come up with. Ready? I'll show you the solution now. All right. So this problem, we begin with obviously just trying to figure out what the problem is. Well, so say we draw a coordinate axis, and they say there's the parabola 12 minus x squared. Let's graph it. Why not? I mean, it's only going to be an approximate graph, but let's see. So we're trying to find the dimension. We'll put an S here, just because why not? Of the rectangle, the largest area. So there's a rectangle and it has its base on the x-axis and its other two vertices above the x-axis is lying on the parabola 12 minus x squared. Such a rectangle exists. So it could be a rectangle like this, rectangle maybe like this. But we're trying to find the one with the largest possible area. And if you're thinking it might be, say, a square, no, it's not. We haven't actually proven that yet. So we can't just say with all certainty it's a square and spoil that it's not. It's not a square. Anyway, so we're here to find the dimensions of this rectangle. And so let's make some key observations first. Firstly, since this entire thing has this vertex at x equals 0, the reason why I know this is, well, let's rewrite this thing as y is equal to negative x squared plus 12. Well, x squared is obviously something like this. So it has its vertex at x equals 0. I drew that badly, but you get the point. It has vertex at x equals 0. When it's negative, it's flipped around like this. Then you just added 12 to it. So its vertex is still at x equals 0. Which means this side over here is the exact same as this side over here. So we only actually have to care about the positive end of this just to make things simpler. And since we have to find the dimensionalized rectangle of the whole thing, we can just double the x coordinate we find, and that'll be the end of it. So let's start. We have an x value right here until like this. So let's say that's going to be our x value. And we have a y value like this. So this will be the y value. This will be the x value. And depending on what x coordinate you put in, you're going to get another y coordinate that still stays on this point. Because that's how this thing is set up, right? So you always get this x and this y, and that's going to be that thing. So what we're trying to find is the maximum value we have of the area while having a positive value for x and a positive value for y. So you can say x times y over here must be equal to well, it's not equal to anything. We're trying to find the largest possible value for it. So, well, we know the value of y here is negative x squared plus 12, right? So we can say we're trying to find the maximum possible value for the expression over here. Expanding it, we can see, say we have negative x cubed plus 12x. Well, yeah, that is what we do. We expand it. We're trying to find the maximum possible x value that you could put in here that is both a positive x value and its output must also be positive. Otherwise, they're not valid side lengths, right? If y is not positive, it's not above the x-axis, as they clearly say here. And x must also be positive, because we're trying to find this side. Well, so the maximum value for this, in case you don't know, the way to find the maximum value is we take its derivative and set it to zero. The reason why we do this is because, say, this is a cubic, so its graph would look something like this. And so, well, we only care about what's on this side over here. And so, right over here is where its vertex is where it turns. And that's why we consider this the maximum possible value. How do I know it's like this and say not like this? Well, we'll see. I'll show you in a minute. So, if you look at this closely, we're trying to find the maximum possible value, right? So, right. Actually, you know what? I'll show you why it's not like that first. Firstly, if it was like this, we would our maximum possible value for x should be infinity. And in this case, I guess it is true. If x is all the way over here, y is all the way down there. That's a huge rectangle. But we are limited, so our area cannot be infinity, as it has to stay between this. Which means we need to find an x coordinate that gives a finite value. So it's going to have to be a vertex like this. To find that, we need to find in this particular example where its slope of the tangent line would be exactly zero. The x coordinate that happens at. So we find the derivative of this, and using the power rule, which I won't show right now, uh it's 3x squared plus 12. And so we have this expression here. Now we just have to set this equal to zero and try and find the derivative. And try and solve this. So we could use the quadratic formula, but the best way to do this, I believe, is to subtract 12 from both sides. So we get negative 3x squared, and we have this equal to negative 12. Since subtracting 12 and adding 12 cancels out, and over here we just get subtract 12. And then we divide both sides by negative 3. So this, so again, it gives us x squared, and it's multiply negative 3 and divide negative 3. They all cancel out, and negative 2 over negative 3 is just 4. And this is simple. We take the square root, well, we technically have to take the real root, and we get the positive or negative 2. Now, why positive and negative? Well, the negative 2 squares to give 4, and so does positive 2. They both square to give 4. But we only care about the positive value of x right now, so we just take positive 2 here and move on. So what have we found? We found that this value right over here must be positive 2. So what's the y coordinate? Well, we can find that as well. We can just plug it in to this expression right here. Hold on, I'm not showing the little stuff. So we can just plug it into that expression right there, and after we plug it in, we can find that, well, we get, let's see, negative 2 squared plus 12, we get negative 4 plus 12, which is equal to 8. So what have we found? This side is 8. Remember, we're trying to find the rectangle of largest area that has its base on the x-axis and two vertices above the x-axis. This means we forgot to consider this side, right? Remember, since the vertex over here, its axis of symmetry is on the y-axis, which means this is 2 and this is 8. And since both of these are 2, we can just add them up together and say 4. So we found the dimensions of this thing, and by all means, I hope you guys had a good time, and I'll see you again in the next video.